This lesson is if you missed class May 4th, 2010. Tonight's homework is on a brand new assignment sheet which I have posted on Edline. Your homework is just assignment number 1. This was the warm-up for today. It was a reminder of last unit. We need to find the cube roots of z given this complex number in polar form. Remember, you find the cube root of r, theta divided by n in this case is 3. That gives us our first answer. There are 3 answers since we're taking the cube root. I do 2 pi divided by n to find the additional 2 answers. So try this problem on your own. Look at your notes. If you need help, come in and ask me. So today's notes were on exponential and logarithmic functions. Today we're just going to focus on exponential functions. So this is our new unit. So if I look at exponential functions, this is the form. Exponential functions have x in the exponent. B is our base, and a is our initial value. The reason why a is our initial value is because if I plug in 0 in for x, which would be the initial, b to 0 power is always going to be 1. Doesn't matter what b is, anything to the 0 power is 1. And when I take 1, multiply it by a, I get a. So the initial value is always going to be the number in front of b to the x. Sometimes it's just 1. B is our base. B has the exponent on it. It's also called our growth factor. So here's example 1. Again, here's the form of exponential functions. Here's our function, 3 times 2 to the x. Go ahead, find the initial value, and find the base. So we found our initial value is 3, and our base is 2. So looking at this function, and we want to graph this function now, the easiest numbers to plug in for x are 0 and 1. So find out what my y values are when I plug in 0 and when I plug in 1. So when I plug in 0, I get 2 to the 0. Anything to the 0 power is 1. I get 1 times 3. So I have the ordered pair 0, 3. That's my initial value. 0, 3 is my ordered pair. Plug in 1. 2 to the first power is 2. 2 times 3 is 6. So we have these 2 points that we have to plot, and we need to graph an exponential function. So when I plot these 2 points, I connect them, and here's the graph, exponential graph. Some of you might remember this as exponential growth. I want you to take a minute, find the domain, the range. Tell me if there are any asymptotes in the graph, and also find the limit as x approaches infinity and the limit as x approaches negative infinity. Okay, so there is a horizontal asymptote. The horizontal asymptote is 0. This graph does not go below the x-axis. The domain is all real numbers. We have x values everywhere. The range is y is greater than 0, everything above the x-axis. The limit as x approaches infinity is infinity. As we go to the right, the graph goes to infinity. The limit as x approaches negative infinity is 0. As we go towards the left, the graph goes towards 0. Here's example 2. Do the same thing for this example. Pause the video, and then press play to check your answers. Again, find the initial value, find the base, graph the function, find the domain, the range, and the end behavior limits.